So we know that g of x is integral -2 to x of f of t dt. And the first problem is just like the second example from this packet, which you may have looked at a while ago, but if you want to pause and try, do that first. Otherwise, answers g of 0 is 2. G prime of 0 is 1. I'm sorry, g prime of 0 is 2. I take that back. The second derivative is 1. So to get those, to find g of 0, we need to plug in 0 for x, so I'm taking -2 to 0 of f of t dt. So the integral from -2 to 0 is the area of this triangle. 1/2 base times height is 2. To get g prime of 0, g prime of x is just going to be f of x, so g prime of 0 is f of 0. And f of 0 is just the y value of this graph, because this is the graph of f, so f of 0 is 2. And then the last part, the second derivative, g double prime at 0, is going to be f prime of 0. And if we look at our graph of f prime is the derivative at this point, and derivative means slope. So if we look at the slope of this section, we get 1, and that's how we get that last value. So try to answer parts B and C before you watch the video. For part B, we are looking for where the graph is concave up, or where the graph of g is concave up. So if we're looking at the derivative of g, then g is concave up wherever f is increasing. So we look for wherever f is increasing. That's going to be -2 to 1 and 7 to 9. For part C, the function is going to be increasing wherever the derivative is positive. Positive is anything above the x-axis, so we have two regions where it's going to be positive. This first section is -2 to 4. And the second section is going to be 8 to 9. And that's it. For part A on this problem, the answers are going to be h of 8 equals 2. H prime of 8 is -2, and this one's tricky, but the second derivative doesn't exist. So to get those, h of 8 is the integral from 0 to 8 of f of t. And we need the area between 0 and 8. I have a triangle, and then this kind of weird space in here. This could be a trapezoid, or it can be a triangle and a square, up to you. But find the total of those areas and you will have your answer. What do I have on my notes? I have -1 plus 8 minus 1 minus 4 is how I set up my areas, and that's how I got 2. H prime of 8 is going to be f of 8, because the derivative of h is going to be f, and that is this point here. F of 8 is -2. like I said, the last part is a little bit tricky. The second derivative, we're looking at f prime of 8. So we need the value of the derivative at this point here, but the problem is that that point is a corner, and at corners, derivatives don't exist. So that one was a little bit of a trick question. For part B, we want a minimum and maximum only on 0 to 8. The first time I did this, I made a mistake by not being careful on my domain. 0 to 8, I'm only looking 0 to 8. Only this first section of the graph, which is essentially the first period of the graph. So on 0 to 8, if we are looking at the derivative of h, we want to know h will have a minimum wherever its derivative goes from negative to positive. And it looks like that happens at x equals 1. So h has a min. And then, oh, I shouldn't be calling this f prime of x. Sorry about that. I really should be calling it h prime of x, or just f of x. So anywhere it goes from positive to negative, we have a maximum value, and that happens at x equals 5. The part C of this question is definitely a critical thinking question. We need to know a point and a slope when x is 35, and to do that, we need to know that this graph is periodic. So see if you can figure out how to do that. And I'm going to give myself a little bit of space to work. Okay. So we need to know two things. We need to know the point. We have 35, comma something. We need to figure out that y value. And then we also need to know the slope. So we need to know h prime of 35. So we need to figure out what these two things are. And to do that, we need to use that this is something that is periodic. So every 8 units, the graph resets. So the first period goes from 0 to 8. The next goes 8 to 16, 16 to 24, 24 to 32. So I'm just going in multiples of 8 or in groupings of 8. And then the last one, we only want to go 32 to 35, even though that wouldn't be the entire period. That would only be part of it. So we have to figure out at an x value of 35, what would the y value be? So we've gone through, to get from 0 to 35, we go through 1, 2, 3, 4 full periods, and then 32, 33, 34, 35, and then 4 units. So that means that the function value is going to be the same as 32, 33, 34, 35, the same as f of 3. And since we know that we're looking at the derivative, this gives us the slope here. So that is going to give us a slope of 4 because we're looking at the derivative. To find the y value, so we need to find h of 35, which is the integral from 0 to 35. The integral from 0 to 35 is the area from 0 to 35. The area of each of these periods, we found that the area of one period was 2. We found that way back when in part A. So the area of each of these periods is 2, 2, 2, 2, 2, 2, until we get to this last one. This last one is only this space here. So that little negative triangle and the larger positive triangle. So that is -1 plus 4. Small triangle, big triangle. So the total of this is going to give us h of 35, which is 11. So h of 35 is the y value, h prime of 35 is the slope. So our final answer, y minus y1 is m times x minus x1. Okay, and that is the final answer. That's the end of this video. If you have any questions, please reach out. I know this part C is a bit of a weird one, so don't hesitate to reach out if you want to try to find a time to meet to go over any of this stuff.